Oh, thank you. Ladies and gentlemen, Mackenzie. Mumbai. So much happening. So much happening. This is, as you know, India, very, very dear to the world's computer industry, central to the IT industry. At the center, at the core of the IT of just about every single company in the world. My industry, your industry, that we've built over the last several decades is going through fundamental change, seismic change, tectonic shifts. Let's talk about that today. But before we start, let me thank all of our partners. There are so many of you working with, please, thank you. Our incredible partners that we're working with here in India to transform the IT industry together. And so I'm delighted that all of you have joined us today. There are two fundamental shifts that are happening at the same time. This hasn't happened since 1964, the year after my birth. It wasn't because of my birth, but in 1964, the IBM System 360 introduced the world to the concept of IT, the IT industry as we know it, introduced the idea of general purpose computing. They described a central processing unit, a CPU, I/O subsystems, multitasking, the separation of hardware and application software through a layer called the operating system. IBM described family compatibility for applications so that you could benefit by the install base of your hardware to run your software over a long period of time. They described architectural benefit across generations so that the investment that you make in software, the investments you make in using the software is not squandered every single time you buy new hardware. They recognized in 1964 the importance of install base, the importance of software investment, the importance of building computers that run the software. Architecture discipline, all described in 1964. I've just described today's computer industry. The same industry of building computers that run the software. Architecture discipline, all described in 1964. I've just described today's computer industry. The same industry that the India IT industry was built from. General purpose computing as we know it has existed for 60 years until now. For the last 30 years, we've had the benefit of Moore's Law. An incredible phenomenon. Without changing the software, the hardware can continue to improve in an architecturally compatible way. And the benefits of that software doubles every year. As a result of doubling in performance every year, depending on what your applications, you're reducing your cost by a factor of 2 every single year. The most incredible depreciating force of any technology the world's ever known. By depreciation, cost reduction, it made it possible for society to use more and more of IT. As we continue to consume IT, as we continue to process more data, Moore's Law made it possible for us to continue to drive down cost, democratizing computing as we know it today. Those two events, the invention of the System 360, Moore's Law with Windows PC, drove what unquestionably one of the most important industries in the world. Every single industry has subsequently been built on top of it, IT. But we know now that the scaling of CPUs has reached its limit. We can't continue to ride that curve, that free ride. The free ride of Moore's Law has ended. We have to now do something different, or depreciation will end. And we now will not enjoy depreciation, but experience inflation, computing inflation. And that's exactly what's happening around the world. We no longer can afford to do nothing in software and expect that our computing experience will continue to improve, that costs will continue to decrease, and continue to spread the benefits of IT and to benefit from solving greater and greater challenges. We started our company to accelerate software. Our vision was there are applications that would benefit from acceleration if we augmented general purpose computing. We take the workload that is very compute intensive and we offload it and we accelerate it using a model we call CUDA, a programming model that we invented called CUDA that made it possible for us to accelerate applications tremendously. That acceleration benefit has the same qualities as Moore's Law. For applications that were impossible or impractical to perform using general purpose computing, we have the benefits of accelerated computing to realize that capability. For example, computer graphics. Real-time computer graphics was made possible because of NVIDIA coming into the world and make possible this new processor we call GPUs. The GPU was really the first accelerated computing architecture running CUDA, running computer graphics, a perfect example. We democratized computer graphics as we know it. 3D graphics is now literally everywhere. It could be used as a medium for almost any application. But we felt that long-term, accelerated computing could be far, far more impactful. And so over the last 30 years, we've been on a journey to accelerate one domain of application after another. The reason why this has taken so long is simply because of this. There is no such magical processor that can accelerate everything in the world. Because if you could do that, you would just call it a CPU. You need to reinvent the computing stack from the algorithms to the architecture underneath and connect it to applications on top. In one domain after another domain, computer graphics is the beginning, but we've taken this architecture, CUDA architecture, from one industry after another industry after another industry. Today, we accelerate so many important industries. cuLitho is fundamental to semiconductor manufacturing, computational lithography, simulation, computer-aided engineering, even 5G radios that we've recently announced partnerships with, that we can accelerate the 5G software stack, quantum computing, so that we can invent the future of computing with classical, quantum, hybrid computing. Parabricks, our gene sequencing software stack. QVS, one of the most important things every single company is working on, is going from databases to knowledge bases so that we can create AI databases. Using QVS, we can create and vectorize all of your data. QDF, data frames. Data frames is essentially another word for structured data. SQL acceleration is possible with QDF. In each one of these different libraries, we're able to accelerate the application 20, 30, 50 times. Of course, it takes a rewrite of software, which is the reason why it's taken so long. In each one of these domains, we've had to work with the industry, work with our ecosystem, software developers and customers, in order to accelerate those applications for their domains. cuOpt, one of my favorites, combinatorial computing application, a very compute-intensive application, for example, the travel salesperson problem. Every supply chain, every driver-rider combination, those applications could be accelerated with cuOpt, incredible speed up. Modulus, teaching an AI the laws of physics, not just to be able to predict the next word, but to be able to predict the next moment in time of fluid dynamics and particle physics and so on and so forth. And of course, one of the most famous application libraries we've ever created called cuDNN, made it possible to democratize artificial intelligence as we know it. These acceleration libraries now cover so many different domains that it appears that accelerated computing is used everywhere. But that's simply because we've applied this architecture, one domain after another domain, that we've covered just about every single industry. Now, accelerated computing, or CUDA, has reached the tipping point. Several years ago, about a decade ago, something very important happened. And most of you have seen the same thing. AlexNet made a gigantic leap in the performance of computer vision. Computer vision is a very important field of artificial intelligence. AlexNet surprised the world with how much of a leap that it was able to produce. We had the benefit of taking a step back and asking ourselves, what are we witnessing? Why is AlexNet so effective? How far can it scale? What else can we do with this approach called deep learning? And if we were to find ways to apply...
Okay, all right. We'll cut back into it, but for now, we'll slip into a short break, but do not go anywhere. It'll be coming up next, and it does not get bigger than this. Coming up next is a fireside chat between Jansen Huang of Nvidia and Mukesh Ambani of Reliance Industries. You have to stay tuned in for this conversation.
Godavari Biorefineries Limited, an integrated biorefinery and manufacturers of ethanol-based chemicals in India, one of India's largest producers of ethanol in terms.
How does it affect the computer industry? And if we wanted to do that, if we believe in that future and we're excited about what deep learning can do, how would we change every single layer of the computing stack so that we could reinvent computing altogether? 12 years ago, we decided to dedicate our entire company to go pursue this vision. It is now 12 years later. Every single time I've come to India, I've had the benefit of talking to you about deep learning, had the benefit of talking to you about machine learning, and I think it's very, very clear now the world has completely changed. Now let's think about what happened. The first thing that happened, of course, is how we do software. Our industry is underpinned by the method by which software is done. The way that software was done, call it software 1.0, programmers would code algorithms, we call functions, to run on a computer. And we would apply it to input information to predict an output. This is basically software 1.0. Somebody would write Python or C or Fortran or Pascal or C++, code algorithms that run on a computer. You apply input to it, and output is produced. Very classically, the computer model that we understood quite well. And it, of course, created one of the largest industries in the world, right here in India, the production of software. Coding, programming became a whole industry. This all happened within our generation. However, that approach of developing software has been disrupted. It is now not coding, but machine learning. Using a computer to study the patterns and relationships of massive amounts of observed data to essentially learn from it the function that predicts it. And so we are essentially designing a universal function approximator using machines to learn the expected output that would produce such a function that would produce such an expected output. And so going back and forth, looking, this is software 1.0 with human coding to now software 2.0 using machine learning. Notice who is writing the software. The software is now written by the computer. And after you're done training the model, you inference the model. You then apply that function now as the input, that function, that large language model, that deep learning model, that computer vision model, speech understanding model, is now an input neural network that goes into the GPU that can now make a prediction given new input, unobserved input. This way of doing software, notice, is based on fundamentally machine learning. And we have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs. This, at its core, is what happened to our industry in the last 10 years. We have now seen a complete reinvention of the computing stack. The whole technology stack has been reinvented. The hardware, the way that software is developed, and what software can do is now fundamentally different. We dedicated ourselves to advance this field. And so this is what we now build. What all of you have initially, when I first met India, we were building GPUs that fit into a PCI Express card that goes into your PC. This is what a GPU looks like today. This is Blackwell. Incredible system that is designed to study data at an enormous scale. Yeah, thank you. A massive system designed to study data at an enormous scale so that we could discover patterns and relationships and learn the meaning of the data. This is the great breakthrough. In the last several years, we have now learned the representation or the meaning of words and numbers and images and pixels and videos, chemicals, proteins, amino acids, fluid patterns, particle physics. We have now learned the meaning of so many different types of data. We have learned to represent, how to represent information in so many different modalities. Not only have we learned the meaning of it, we can translate it to another modality. So one great example, of course, is translating English to Hindi. Translating English, large body of text, into other English, summarization. From pixels to image recognition. From words to pixels, image generation. From images, videos, to words, captioning. From words to proteins used for drug discovery. From words to chemicals, discovering new compounds. From amino acids to proteins, understanding the structure of proteins. These fundamental ideas, essentially a universal translator of information from any modality to another modality, has led to a Cambrian explosion of the number of startups in the world. They're applying the basic method I just described. If I could do this and that, what else can I do? If I can do that and this, what else can I do? The number of applications has clearly exploded. In the last couple, 2-3 years, the number of generative AI companies around the world, tens of thousands, tens of billions of dollars have been invested in this field, all because of this one instrument that made it possible for us to study data at enormous scales. Well, I just want to say that in order to build the Blackwell system, of course the Blackwell GPU is involved, but it takes 7 other chips. TSMC manufacture all of these chips, and they're just doing an extraordinary job ramping the Blackwell system. This is Blackwell is in full production, and we're expecting to deliver in volume production in Q4. And so this is basically Blackwell. Now, this is one of the things that's really incredible about the system. Let me show it to you. Oh, nothing's easy this morning. This is NVLink. and it goes across the entire back spine of a rack of GPUs. And these GPUs are all connected from the top to the bottom using NVLink, driving these incredible SerDes, the world's longest driving SerDes for copper. And it connects all of these GPUs together. 72 dual GPU packages of Blackwell's, 144 GPUs, connected together, so it's one giant GPU. If I were to spread out all of the chips to show you what this connects together, it's essentially a GPU so large, it'd be like this big. But it's obviously impossible to build GPUs that large, so we break it up into the smallest chunks we could, which is reticle limits and the most advanced technologies, and we connect it together using NVLink. And so this is NVLink backspine. You're looking at all of the GPUs being connected. That's the quantum switch that connects all of these GPUs together on top. Spectrum-X, if you would like to have Ethernet. And in what connects this together, this is like 50 pounds. I'm just demonstrating how strong I am. This is connected to this switch. And this is one of the most advanced switches the world's ever built. Now, all of this together represents Blackwell. And then it runs the software that's on top. The CUDA software, cuDNN software, Megatron for training the large language models, TensorRT for doing the inference, TensorRT LLM for doing distributed multi-GPU inference for large language models. And then on top of that, we have two software stacks. One is NVIDIA AI Enterprise that I'll talk about in a second, and then the other is Omniverse. I'll talk about both of those in a second. This job is surprisingly rigorous. So this is the Blackwell system. This is what NVIDIA builds today. And for those of you who have known us for a very long time, it's really quite surprising how the company has transformed. But literally, we reasoned from first principles. We reasoned from first principles how computing was going to be done in the future, and this is Blackwell. Now, the Blackwell system is extraordinary. Of course, the computation is incredible. Each rack is 3,000 pounds, 120 kilowatts, 120,000 watts in each rack. The density of computing, the highest the world's ever known. And what we're trying to do is to learn larger and smarter models. It's called the scaling law. The scaling law comes from the fact that the empirical observation and measurements that suggests the more data you have to train a large language model with, and therefore the correspondingly large model size, the more information you want to learn from, the larger the model has to be, or the larger model you would like to train, the more data you need to have. And each year, we're increasing the amount of data and the model size, each by about a factor of 2, which means that every single year, the computation, which is the product of those two, has to increase by a factor of 4. Now remember, there was a time when the world, Moore's law was 2 times every year and a half, or 10 times every 5 years, 100 times every 10 years. We are now moving technology at a rate of 4 times every year. 4 times every year over the course of 10 years, incredible scaling. And we continue to find that AI continues to get smarter as we scale up the training size. The second thing that we've discovered recently, and this is a very big deal, after you're done training the model, of course, all of you have used ChatGPT. When you use ChatGPT, it's a one-shot. You give it a prompt. Instead of writing a program to communicate with a computer today, you write a prompt. You just talk to the computer the way you talk to a person. You describe the context, you describe what it is you're querying about, You could ask it to write a program for you. You could ask it to write a recipe for you, whatever question you would like to have. And the AI processes through a very large neural network and produces a sequence of answers, producing one word after another word. In the future, and starting with Strawberry, we realize that, of course, intelligence is not just one shot, but intelligence requires thinking. And thinking is reasoning, and maybe you're doing path planning, and maybe you're doing some simulations in your mind. You're reflecting on your own answers. And so as a result, thinking results in higher quality answers. And we've now discovered a second scaling law. And this is a scaling law at a time of inference. The longer you think, the higher quality answer you can produce. This is not illogical. This is very, very intuitive to all of us. There are some problems. For example, what's my favorite? If you were to ask me, what's my favorite Indian food, I would tell you chicken biryani. Okay? And I don't have to think about that very much, and I don't have to reason about that. I just know it. And there are many things that you can ask it. Like, for example, what's NVIDIA good at? NVIDIA is good at building AI supercomputers. NVIDIA is great at building GPUs. And those are things that you know that it's encoded into your knowledge. However, there are many things that requires reasoning. For example, if I had to travel from Mumbai to California, and I want to do it in a way that allows me to enjoy 4 other cities along the way. Today, I got here at 3 a.m. this morning, and I got here through Denmark, and right before Denmark, I was in Orlando, Florida, and before Orlando, Florida, I was in California. Okay, and so that was 2 days ago, and I'm still trying to figure out what day we're in right now. But anyways, I'm happy to be here. If I were to tell it, I would like to go from California to Mumbai, and I would like to do it within 3 days, and I give it all kinds of constraints about what time I'm willing to leave and able to leave, what hotels I like to stay at, so on and so forth, the people I have to meet. The number of permutations of that, of course, quite high. And so the planning of that process, planning and coming up with an optimal plan is very, very complicated. And so that's where thinking, reasoning, planning comes in. And the more you compute, the higher quality answer you could provide. And so we now have 2 fundamental scaling laws that is driving our technology development. First for training, and now for inference. And so we're going to deliver Blackwells by the Q4 timeframe of this year, and shipping out to customers. And the demand for Blackwells is incredible. And the reason for that is this. The number of foundation model makers has more than doubled since the beginning of Hopper. There are more companies that realize that fundamental intelligence is vital to their company, and that they have to build foundation model technology. And second, the size of the models have increased by 20, 30, 40x the amount of computation necessary to train these models because of the size of the models, but also multimodality capability, reinforcement learning capability, synthetic data generation capability. The amount of data that we use to train these models has really grown tremendously. And so that's one. And then the other reason, of course, is that Blackwell is also used for generating tokens at incredible speeds. And so together, all of these factors has led to the demand for Blackwell being incredibly high. Let's talk about now how we're going to use this technology. This is the headline I thought was really good. NVIDIA is AI in India. Now, aside from the letter V, you could use NVIDIA to create the rest of that sentence, which I thought was really cool. Now, thank you. You don't know this story, but in 1993, we had to come up with a name for our company, and the reason why we chose NVIDIA, I'll do the extreme short version. The reason why I chose NVIDIA in the end was because I really love NVIDIA sounds like a mystical place. And so yes, India, NVIDIA. and sounded like a great place. And so if it turns out that computer graphics and accelerated computing didn't work out for us, we could do almost anything. And so I'm just happy it worked out. Okay, so NVIDIA in India. We have a really rich ecosystem here. The first thing that you have to realize is that in order to build an AI ecosystem in any industry or in any country, you have to start first with the ecosystem of the infrastructure. And we announced that Yoda, that ETE, Tata Communications, and our other partners are joining us to build fundamental computing infrastructure here in India. And in just 1 year's time, by the end of this year, we will have nearly 20 times more compute here in India than just a little over a year ago. That's the amount of infrastructure we're getting. Yep. So the first part of building an AI ecosystem is the AI infrastructure, just as the first part of infrastructure for the internet ecosystem was building the infrastructure of networking. Of course, the infrastructure of networking internet consists of the personal computer, cloud, and internet itself. In the case of AI, it starts with the AI computing infrastructure. The next part, the operating system of AI, is large language models. And we've worked with partners here in India to build the Hindi large language model. And Hindi large language model, as you know, there's 25 different formal languages here in India, with apparently a new dialect every 1,500 kilometers. And so you don't have to go very far before you need to train another model. And so here in India, if anybody, this is the hardest language model region in the world. And if anybody could do it, you can do it. And once India figures out how to create the Hindi large language model, you can figure it out for every other country. So, And so the next layer is the application layer above that. And working with us to bring AI to the ecosystem of India, of course, AI native companies that are creating new applications that are made possible only with AI. And then our service partners from Wipro to Infosys to TCS, working with us to take the AI models and the AI infrastructure out to the world's enterprises. Now, that's NVIDIA in India. I'm going to have Vishal, our country leader, come join me on stage, because I would love for him to talk to you about some of the companies that we're working with here in India. Vishal? Vishal Tupar? Okay, so I'm going to introduce a couple of other ideas. And so earlier I told you that we have Blackwell. We have all of the libraries, acceleration libraries that we were talking about before. But on top, there are two very important platforms we're working on. One of them is called NVIDIA AI Enterprise, and the other is called NVIDIA Omniverse. And I'll explain each one of them very quickly. First, NVIDIA AI Enterprise. This is a time now where the large language models and the fundamental AI capabilities have reached a level of capabilities we're able to now create what is called agents. Large language models that understand the data that, of course, is being presented. It could be streaming data, it could be video data, language model data, it could be data of all kinds. And the first stage is perception. The second is reasoning about, given its observations, what is the mission and what is the task it has to perform. In order to perform that task, the agent would break down that task into steps of other tasks. And it would reason about what it would take, and it would connect with other AI models. Some of them are good at, for example, understanding PDF. Maybe it's a model that understands how to generate images. Maybe it's a model that is able to retrieve information, AI semantic data from a proprietary database. So each one of these large language models are connected to the central reasoning large language model we call agent. And so these agents are able to perform all kinds of tasks. Some of them are maybe marketing agents. Some of them are customer service agents. Some of them are chip design agents. NVIDIA has chip design agents all over our company helping us design chips. Maybe they're software engineering agents. Maybe they're able to do marketing campaigns, supply chain management. And so we're going to have agents that are helping our employees become super employees. These agents or agentic AI models augment all of our employees to supercharge them, make them more productive. Now, when you think about these agents, it's really the way you would bring these agents into your company is not unlike the way you would onboard someone who's a new employee. You have to give them training curriculum. You have to fine-tune them, teach them how to use, how to perform the skills, and understand the vocabulary of your company. You evaluate them, and so there are evaluation systems. And you might guardrail them. If you're an accounting agent, don't do marketing. If you're a marketing agent, don't report earnings at the end of the quarter, so on and so forth. And so each one of these agents are guardrailed. That entire process we put into essentially an agent lifecycle suite of libraries, and we call that NeMo. Our partners are working with us to integrate these libraries into their platforms so that they could enable agents to be created, onboarded, deployed, improved into a lifecycle of agents. And so this is what we call NVIDIA NeMo. We have, on the one hand, the libraries. On the other hand, what comes out of the output of it is an API inference microservice we call NIMs. And so essentially, this is a factory that builds AIs. And NeMo is a suite of libraries that onboard and help you operate the AIs. And ultimately, your goal is to create a whole bunch of agents. We have partners here that we're working with in India. And Vishal, if you could tell everybody about our ecosystem here.
Absolutely, Jensen. The word that stuck me as I was standing behind was a word called mystique. This is the mystique of India. Jensen was here exactly 12 months back, and he asked me a pretty profound question, that the rich tapestry of India, how are you going to encode it? And it all began from the infrastructure. As mentioned, in just 12 months, today we have computing from Yotta, which has built the state-of-the-art infrastructure. Tatas are going live. E2E has been in existence, giving us accelerated computing infrastructure for a long, long period of time. All this computing helped us to leapfrog to solve one of India's largest problems. That is about communication. Like Jensen said, we speak in so many languages. He did say 1,500 kilometers, but all of you know, every 50 kilometers, we change our dialect. We don't only speak English, we speak English, and if you are from South, there'll be a little bit of Malayali also added into it. So how do we make this really work is the work of some of our partners. Servam is a classical example. Servam basically started their efforts to basically help India talk. They decided we're going to do voice-to-voice. And while doing voice-to-voice, they had to understand how does this language work, which is multimodal, how do we make sure that it performs, and they came into existence pretty quickly because there was infrastructure that was available to us. Similarly, we saw projects coming from Bharat GPT. Again, a work that has been done predominantly in academia. The academia in India has been rich with ideas. And every time they wanted an idea to be translated into reality, they need infrastructure. Today, the work that we are doing in IITs, the work that we are doing at different organizations is all a result of coming together, solving the critical issue that India has. Not only was the language getting solved, we also realized very quickly that there are many mega challenges that India has. And one of the...
It's almost lunchtime.
Yes.
But take your time.
Okay, just one more thing.
Okay, yeah.
Just one more thing. Health.
No one loves India more than Vishal.
A well-spoken Indian and a healthy Indian always make a difference, and that's why we have companies who've been working on health. As many of us know, it's been challenging. How do we look after our health? But diagnostics coming from SickTuple, Cure.ai is really helping us solve many of these challenges. So with that promise, Jansen,
That's awesome.
healthy
Yep.
and well-spoken.
Healthy and well-spoken. And the important thing here, it takes an entire ecosystem of partners to be able to help the world apply AI to help their employees be more productive. And this is, whereas India was focused on IT, the back office, operations of software, the delivery of software, producing software. The next generation of IT is going to be about producing and delivery of AI. And as you know, the delivery of software, coding, and the delivery of AI is fundamentally different, but dramatically more impactful, insanely more exciting. And the ability for this industry, for India, to help every single company around the world to enjoy the benefit of agents, to enjoy the benefits of AIs across all of their different functionalities, and to be able to deploy it at scale, I don't know anybody else who could do it. This is just an extraordinary opportunity. Our job is to help you build AI and deploy AI. To build AI and deploy AI. Your job is to take these libraries and the capabilities that we have, combine it with your incredible IT capabilities, software capabilities, so that we can create agents and help every single company benefit from it. And so this is the first part. The second part is this. What happens after agents? Now remember, every single company has employees, but most companies, the goal is to build something, to produce something, to make something. And those things that people make could be factories, it could be warehouses, it could be cars and planes and trains and ships and so on and so forth. All kinds of things. Computers and servers, the servers that NVIDIA builds, it could be phones. Most companies in the largest of industries ultimately produces something. It's sometimes production of service, which is the IT industry, but many of your customers are about producing something. That next generation of AI needs to understand the physical world. We call it physical AI. In order to create physical AI, we need 3 computers, and we created 3 computers to do so. The DGX computer, which this AI Blackwell, for example, is a reference design and architecture to create things like DGX computers for training the model. That model needs a place to be refined. It needs a place to learn. It needs the place to apply its physical capability, its robotics capability. We call that Omniverse, a virtual world that obeys the laws of physics, where robots can learn to be robots. And then when you're done with the training of it, that AI model could then run in the actual robotic system. That robotic system could be a car, it could be a robot, it could be a autonomous moving robot, it could be a picking arm, it could be an entire factory or an entire warehouse that's robotic. And that computer we call AGX, Jetson AGX, DGX for training, and then Omniverse for doing the digital twin. Now here in India, we've got a really great ecosystem who is working with us to take this infrastructure, take this ecosystem of capabilities to help the world build physical AI systems.
And you know what I've really loved is Adverb is one of the largest robotics company. They build robotics, and more importantly, they put it in a digital twin where optimization takes place. They teach the robo all the inputs that comes out of the physical world. Not only is that work taking place, our system integrators, Accenture, TCS, Tech Mahindra, are taking that knowledge not only into India, but also outside India. So do it in India, for India, and do from India for globe.
Start locally, grow globally.
Right.
Right, that's fantastic. Okay.
Thank you. Thank you.
Thank you very much, Michelle.
Thank you.
Thank you. We made a short video to help you put everything together that I just said. Run it, please.
For 60 years, Software 1.0, code written by programmers, ran on general-purpose CPUs. Then, Software 2.0 arrived, machine learning neural networks running on GPUs. This led to the big bang of generative AI, models that learn and generate anything. Today, generative AI is revolutionizing $100 trillion in industries. Knowledge enterprises use agentic AI to automate digital work.
Hello, I'm James, a digital human.
Industrial enterprises use physical AI to automate physical work. Physical AI embodies robots like self-driving cars that safely navigate the real world, manipulators that perform complex industrial tasks, and humanoid robots who work collaboratively alongside us. Plants and factories will be embodied by physical AI, capable of monitoring and adjusting its operations, or speaking to us. NVIDIA builds 3 computers to enable developers to create physical AI. The models are first trained on DGX. Then, the AI is fine-tuned and tested using reinforcement learning physics feedback in Omniverse. And the trained AI runs on NVIDIA Jetson AGX robotics computers. NVIDIA Omniverse is a physics-based operating system for physical AI simulation. Robots learn and fine-tune their skills in Isaac Lab, a robot gym built on Omniverse. This is just one robot. Future factories will orchestrate teams of robots and monitor entire operations through thousands of sensors. For factory digital twins, they use an Omniverse blueprint called Mega. With Mega, the factory digital twin is populated with virtual robots and their AI models, the robots' brains. The robots execute a task by perceiving their environment, reasoning, planning their next motion, and finally converting it to actions. These actions are simulated in the environment by the World Simulator in Omniverse, and the results are perceived by the robot brains through Omniverse sensor simulation. Based on the sensor simulations, the robot brains decide the next action, and the loop continues, while Mega precisely tracks the state and position of everything in the factory digital twin. This software-in-the-loop testing brings software-defined processes to physical spaces and embodiments, letting industrial enterprises simulate and validate changes in an Omniverse digital twin before deploying to the physical world, saving massive risk and cost. The era of physical AI is here, transforming the world's heavy industries and robotics.
Before I wrap up, I want to introduce you to somebody I met today, and there's a superstar in the audience, and I think all of you would love to know who's also interested in technology and artificial intelligence. Akshay Kumar. Akshay and I have many things in common. For example, both of us have been doing our jobs for over 3 decades. One of us is a martial artist. And one of us has 80 million followers.
Hello, everyone.
Unbelievable.
Well, I especially told you not to call me the superstar word. I especially told you.
I know he did. He did. He did. But
I think there was
ladies
one
and
superstar
gentlemen,
I know who was my father-in-law, Mr. Rajesh Khanna.
he absolutely insisted I do not say that. He is so humble. But can we all agree he's a superstar? So you and I, we started our careers around the same time.
Yeah, we
Now
started
you've achieved a level of artistry that
I'm still trying to.
you're. So the two of us, I started when I was 29 years old. NVIDIA. I don't mean.
You and I have something in common. We both started from Thailand.
Thailand. That's right.
Thailand
We
was-
both grew up in Thailand, in Bangkok, and we were just speaking Thai. He went to Thailand. He went to Thailand to learn how to be a martial artist. I went to Thailand just to grow up, but
Well, I had no other choice. I mean, so that was one place which was cheap enough for me to go there, and my parents couldn't afford it, so that was the place. I went there. I wanted to learn, and it so happened that today martial art has helped me where I am. I call myself a stuntman first and an actor later.
so tell me, both of us, we've been doing really the same job for about 30 years.
Right.
And constantly.
The same job?
Literally exactly the same job.
Okay.
And constantly striving to heighten, elevate our artistry, elevate our craft, constantly striving to be better. And so when you look back on your career, what are some of the things that you would say are really fundamental to you being here today and really helped you achieve what you've achieved?
What has been there what I have achieved in life, and what are the fundamental things that you want?
Yeah, what are your characteristics? What do you think some of the core values or your nature that has
I
led
think
to
one of the biggest thing has been self-discipline. That's always been there, which has helped me throughout. It's been like 34 years now in this industry. This industry has given me a lot. And it's one thing is important for me is self-discipline, which has got me where I am today. So that's the main part, which it is. And I always believe, and I always say to people that, guys, make your children get into martial art. Discipline them up. It is one of the best thing and a very, very, very important thing. Your children are also in
That's
martial
right.
art.
Both of my children are second-degree black belts.
Here we go.
Yeah.
That's perfect. It's the most important thing. That's what it has been. There.
It gives them something to be good at.
Yep.
Something they could be proud of. When you're good at anything, it gives you confidence to do everything else. And of course, martial arts, it teaches you discipline, but the other thing that you have an abundance of is humility. You're just incredibly humble. And martial arts also teaches you that.
It teaches you. It teaches you a lot of that. It teaches you, gives you good confidence. And I would like to know something from you.
You're probably wondering how I stay so disciplined. I'm just saying.
You are.
Have you noticed? We're both martial artists.
You are. You have done a great job with yourself. You're 61.
That's what the record shows.
Then what is that is what the AI shows.
That's what the record shows. I think I'm crawling up on 62, but yeah.
Okay, so I think you have maintained your.
You're 42?
No. 37. Okay.
And the two of us been doing the job for 30 years each.
That's true.
He started when he was 7. I started when I was 29.
Well, my Hindi film industry has never made a film on AI. And like we have a robo bani thi. वो हिंदी पिक्चर नहीं थी लेकिन
All I know is Akshay says, Jensen, you have to watch my last movie. It's about super cops.
I know it's going to release now.
Yeah, yeah.
It's going to release
yeah.
now. It's
I can't tell you about it. It's a secret. He told me about it. It's about super cops.
okay. Yeah, I must say, I must admit that you keep the secret very well. Well, what I want to know is, what is one thing which AI can't copy from humans? Which I would like to know that. What kind of a thing would it be that humans can do but AI can't?
Yeah.
And
yeah. Actually, it's an excellent question. And in fact, this is probably the single most vital question for now.
Right.
Which is, what are all the things that AI can do? What can it do? It turns out that as we speak, AI has no possibility of doing all of what we do. However, depending on the jobs that we do, sometimes it could do 20% of our jobs, 20% of our work, 1,000 times better. For some people, it might be able to do 50% of their job, 1,000 times better. But in no job can they do all of it. And so this is the great observation. Because of that, every one of us should apply AI to automate, to become an assistant to help us with that either 20%, 40%, or 50%. People ask me, Jensen, is AI going to take your job? And I tell them, absolutely not. The person who uses AI to automate that 20% or 50% is going to take your job. And so that's right. That's right. And so the most important thing for us right now is to build amazing AIs, build safe AIs. That's good engineering discipline, good engineering business, good engineering process, methodologies, technologies, all come together so that we can build safe AIs. It's like building a safe airplane. The automation systems with diversity and redundancy, all of the backup systems makes it possible for air travel, the airplane to be safe and air travel to be safe. The same ideas will apply to artificial intelligence. I think that long term, I'm really hoping that all of us have our own AI, co-pilots and AI partners that are with us all the time, remembering things, helping us.
That'd be a safe world?
That would be a wonderful world. That would be a wonderful world.
No, it won't be like something like what they show in Hollywood films, that AI is taking over humans.
No, because along the way, amazing engineers like all the people in this audience,
right?
You're talking to basically engineers, a whole bunch of computer scientists. Right. It is our fundamental mission to enable AI to be realized for the benefits of society, but doing it in a way that is systematically safe. And not only do we make the AI safe, we create other AIs to keep it safe. We create other AIs to watch each other, make sure that it's used properly. Of course, there will always be people who will try to use this technology in nefarious ways. But it is up to all of us to advance the technology so that we have access to this incredible capability to keep society safe.
So there can be people who can use it in the wrong side also?
Sure, like all things.
They can.
Yeah, but the good news is there are more people who are good than there are people who are not good. And we have to have access to the technology so that we can keep the rest of the world safe.
Completely.
Yep.
There, one more last question I just want to ask you. How many hours do you sleep?
Last night, I arrived at 3 o'clock. I was up at, I guess, 6:30. And so...
That was only today, for 3.5 hours.
But I'm 100%. This is it, 100%.
100% on it?
Yeah, this is fine.
So do you do some kind of yoga or something?
No.
Or is it because
on the weekend, I catch up on the other 100%.
Perfect. Thank you, sir.
Akshay Kumar.
Thank you.
Unbelievable.
Thank you.
Thank you. So what is it that we've spoken about? Let me close very quickly about artificial intelligence. Now remember, I just said, on first principles, we've reinvented the whole computing stack. From coding to machine learning, from running code on CPUs to running neural networks on GPUs, from developing software to now developing artificial intelligence. We also imagined the two most general versions of artificial intelligence. One is agents, essentially assistants for ourselves. Agents for all kinds of different parts of our job. Assistants that help us be more productive, do superhuman things. And the other, robots, essentially physical versions of agents. These two general purpose agents or robots are being built right now as we speak, and the technologies are available. NVIDIA's job is to create the technology to help you build AIs and agents and help you deploy it. Now, what happens when we do that at scale? Remember, India used to be a country that produced software. You exported software. In the future, India is going to export AI. When you export AI, that's right. In order to create AI and produce AI, you need a machinery. These AI infrastructures we've been talking about. These machines would take energy and transform them to what is called tokens. These tokens are floating point numbers. And these numbers reconstitute, depending on its modality, into artificial intelligence. Artificial intelligence, digital intelligence, one of the most valuable commodities we know. And so the future is going to have a new industry. And this new industry is the production of intelligence. This is production of intelligence at enormous scale. That's the reason why I say there's a new industrial revolution. A singular factory singular concept of a factory running all these different process, all these different creating these models, generating and producing intelligence and tokens.
In Hindi, as we are all determined to make the best LLM in Hindi, right? In Hindi, Vidya means knowledge.
I knew I named the company right. I knew it.
So
everybody said, NVIDIA, what a horrible name. You will never make it.
What it means.
I knew it. I stuck with it.
So you can take credit for this interpretation.
Gosh.
No problem. When you actually devote yourself sincerely to the goddess of knowledge and you acquire knowledge, then in our tradition, the goddess of prosperity, which is Lakshmi, follows. So what you are doing...
32 years ago, I knew this.
So
and now the story of NVIDIA has been revealed to all of you.
So our first principles, right, are what you are driving.
Thank you.
Is the knowledge revolution converting into the into what I call the intelligence revolution. And that drives prosperity across the world for all the 8 billion people. And I think that what we are at the doorsteps of is the new intelligence age. And on behalf of everybody, I am very proud to have you as my friend, and welcome to India, and thank you for actually contributing to the world to bring the intelligence age in our lifetime, and hopefully together with everybody, this can drive to more prosperity for all the 8 billion people in the world, and particularly the 1.5 billion people in India.
Mukesh, it is such an honor and such a great privilege and incredible joy to be able to contribute in this way. And as you know, the IT industry of India is world-renowned for its very large scale, and not just in size, but in deep expertise of computer science. Very few countries in the world has this natural resource, this amazing natural resource called IT and computer science expertise. In the last couple of years, we've been working together to upskill, and we've now upskilled about 200,000 IT professionals into the world of AI. You know, what do we have to do together, and how can we work together to help transform India at the speed of light, really? Because everything is moving so fast. To transform India into a center, not of just IT, but a center of AI.
So, from my point of view, Jansen, let me tell you my own experience in India. First, right, as our Prime Minister has said, that this is a new aspirational India. What we have today is we are among the only country in the world where the average age of 1.4 billion Indians is below 35. So what is driving our economy is not only new technologies like AI, but also aspirations. And I believe that, you know the Prime Minister, and I believe that his leadership in terms of converting India to a premier digital society has been vital and continues to drive activity at the ground level. So it's demography, it's leadership. The third factor is that we as Indians have the raw talent. You talked about converting 200,000 people into this, but I believe there are millions. Right? If we now see India has become home, right, among all the companies across the world, we are our fastest growing industry is global competency centers. So we do space research in India, we do pharmaceutical research in India. I'm sure that you're thinking of building chips in India.
That's right.
We are in terms of where we are and not the manufacturing hub.
And so you know, we have over 10,000 engineers here in India ourselves.
So that's like our challenge. What we also have is we also have what I call the necessary infrastructure, and we've been fortunate that we have the connectivity infrastructure, which is equivalent to the roads. So if you don't have roads, you will not reach your destination. So I believe that today, apart from the US and China, right, India has the best digital connectivity infrastructure, 4G, 5G, and broadband in the world.
Yeah.
Right? When people talk about Geo, and you know, we said Geo took India from number 158 in the world to number 1 in the world in 8 years. And we, as a single company, didn't know anything about this domain, right? But today, we are the largest data company in the world, right?
Yeah.
Our volumes are equivalent to AT&T, T-Mobile, and Verizon combined.
Yeah.
So,
I would say size of local market is quite an advantage.
but let me tell you, like, the most satisfying piece, and
well, having 1.5 billion customers would do it.
The best part's still coming.
That's pretty satisfying.
So the most satisfying piece is that as Geo, we delivered about 16 exabytes of data this year, or we will deliver this year. And the average, in the US, you pay $5 a GB. In the world average for data is about $3.50 a GB. In India, Geo delivers data at 15 cents a GB. And what that means is...
Do you encourage your customers to use their phones?
We do. And what really that means, Jansen, is a perpetual value.
Yeah.
Right? That technology has delivered customer value of between $500 and $700 billion a year on year, every year, and to Indians. And this is the gift of technology to the people of India. And this is what you described as intelligence, we can do to actually bring prosperity to all the people and bring equality to the world. And that is the opportunity, why I described this. And this is the reason that India will be one of the biggest intelligence markets. And it's not only our aspirations, but I think it is just the raw gene pool and the raw gene power that exists in India, the youth power that exists in India, that is actually going to drive intelligence, and hopefully once we drive intelligence for our domestic market, right? We will use intelligent services beyond software to integrate with the rest of the world.
That's right.
And Indians now will not only export CEOs to the world's largest companies, but hundreds of millions of Indians.
It's true. It's true. All of my colleagues, all of my friends back home, they're all Indians. All of my CEOs.
And hundreds of millions will deliver to the
Satya,
world AI
Sundar,
services
and, yeah,
to
Shantanu.
help a better world.
Yeah.
And that is why your being here,
Thank you.
right, is important. Your commitment to this country is important, and working together, right? This cannot be done by any one company, any one individual, but we all have to work together to bring this intelligence age safely to the world so that we can create a more equal world, a prosperous world, and allow the global south to catch up with the rest of the world.
Yeah, that's really terrific. And you know, one of the things that you've highlighted is just the immense amount of digital data that's available, surely at Geo and in India, and this leads to one of the things that I want to announce with you. As you know, in order to lead in artificial intelligence, you need to have AI model technology that India has. You need to have data, massive quantities of data, and using the last thing you need is AI infrastructure. And we're announcing that Reliance and Nvidia are partnering to build AI infrastructure here in India.
Absolutely.
And then the thing that I will say is that in order ultimately to create that into a flywheel is one of the great advantages that India has, which is a very large population of users. And so now you have the fundamental ingredients, AI, data, and AI infrastructure, and you have a large population of users that ultimately creates your AI flywheel. The thing that I really love, and when I met Modi ji, the first time he asked me to meet his cabinet was this has got to be about 6 years ago. He asked me to address his cabinet about artificial intelligence. And I was so surprised. It was literally the first time any government leader, any national leaders asked me to address his cabinet on this.
மும்பை ஜியோ கலாச்சார மையத்தில் NVIDIA நிறுவனத்துடன் ரிலையன்ஸ் குழும தலைவர் முகேஷ் அம்பானி கலந்துரையாடிய காட்சிகளை பார்த்தோம். இடைவேளைக்கு பிறகு தொடரும் மற்ற செய்திகளை பார்க்கலாம்.
Has delivered customer value of between 500 and 700 billion dollars a year on year, every year, to Indians. And this is the gift of technology to the people of India. And this is what you described as intelligence, we can do to actually bring prosperity to all the people and bring equality to the world. And that is the opportunity, why I described this. And this is the reason that India will be one of the biggest intelligence markets. And it's not only our aspirations, but I think it is just the raw gene pool and the raw gene power that exists in India, the youth power that exists in India, that is actually going to drive intelligence, and hopefully once we drive intelligence for our domestic market, right? We will use intelligent services beyond software to integrate with the rest of the world.
That's right.
And Indians now will not only export CEOs to the world's largest companies, but hundreds of millions of Indians.
It's true. It's true. All of my colleagues, all of my friends back home, they're all Indians. All of my CEOs.
And hundreds of millions will deliver to the world AI
Sundar,
services
Shantanu.
to help a better world. And that is why your being here,
thank you,
right, is important. Your commitment to this country is important, and working together, right? This cannot be done by any one company, any one individual, but we all have to work together to bring this intelligence age safely to the world so that we can create a more equal world, a prosperous world, and allow the global south to catch up with the rest of the world.
Yeah, that's really terrific. And you know, one of the things that you've highlighted is just the immense amount of digital data that's available, surely at Geo and in India. And this leads to one of the things that I want to announce with you. As you know, in order to lead in artificial intelligence, you need to have AI model technology that India has. You need to have data, massive quantities of data. And using the last thing you need is AI infrastructure. And we're announcing that Reliance and Nvidia are partnering to build AI infrastructure here in India.
Absolutely.
And then the thing that I will say is that in order ultimately to create that into a flywheel is one of the great advantages that India has, which is a very large population of users. And so now you have the fundamental ingredients, AI, data, and AI infrastructure, and you have a large population of users that ultimately creates your AI flywheel. The thing that I really love, and when I met Modi ji, the first time he asked me to meet his cabinet was this has got to be about 6 years ago. He asked me to address his cabinet about artificial intelligence. And I was so surprised. It was literally the first time any government leader, any national leaders asked me to address his cabinet on this particular topic. It was long before anybody was talking about artificial intelligence. And my last visit with him, he said this, and it was really quite profound. He said, I was explaining to him the concept of AI infrastructure and why it's essential for every nation to have their own AI infrastructure, like their own communication, their internet infrastructure, their roads, like energy, of course, and of course, intelligence should be part of your infrastructure, and the manufacturing of intelligence should be part of your infrastructure. And he said this, he said, it makes complete sense that India should manufacture its own AI, manufacture your own AI. You should not outsource, you should not export data to import intelligence. That India should not export data to import intelligence. And he said,
absolutely.
And Modi ji said, it's like India should not just export flour to import bread. We should add value to the data ourselves. And the partnership that we have is to start that journey, to build the underlying infrastructure so that India could have your own infrastructure. You surely have your own computer science expertise. And you also have your data. You have a giant population of users to drive that flywheel. And then one more comment. This is the thing that he was most inspired by 6 years ago. He said that artificial intelligence has the ability to elevate the entire population of India. And the reason for that, I was talking earlier to him about the fact that there are so few people in the world who knows how to program a computer. Programming is not easy. Here in India, it's the largest population of any programmers in the world. However, still programming is not easy. Most people don't know how to program Python or C++ or Pascal or Fortran, or Java. But everyone knows how to program an intelligence. And so the ability to program computers is available to a small population, but the ability to program AI is something that everyone can do. And if AI could be put into the hands of every citizen, it would elevate and put into the hands of everyone this incredible capability you and I get the benefit from, called computers. And this computer could now benefit everybody in society. And that, he explained that back to me. Yeah.
Absolutely. And I think that is why I started by saying that we are very fortunate to have a visionary leader who believes not only in vision, but in execution.
Yeah.
And Jensen, where I see our partnership and is really, in a sense, I was waiting for your GB200s to mature, because like you from first principles, I don't like doing anything but the best technology. And now your GB200, right, is undoubtedly the best technology. And
Mukesh,
I'm looking forward.
all of my technology is the best technology.
India,
including the next one.
India will start with what is the absolute best that you have. And I'm happy to, like, what we are doing at Jamnagar is we are now ready for big scale up. So we are building infrastructure, right? And we think big. So we're building infrastructure for 1 gigawatt, which can be expandable to multiple gigawatts at one location. We already have the green power so that we are not dependent on anybody else for power. We are building this so that we can scale this, and as your multiple order of magnitude technologies come, we will build our infrastructure, and we will, one important piece that I believe is important is that for India and Indians, right, we have to repeat a geo for intelligence to be really affordable, available to the common people.
Yeah.
And towards that, it is important that we design and build infrastructure so that to use AI, our customers don't have to change a phone, don't have to change their computers, but they can still get good quality AI, and we take the burden of putting that infrastructure together.
Yeah.
And I think that is what we are counting on you and us to do. On top of that, right, I have, again, great respect for my friend Mark Zuckerberg. A state-of-the-art model, and surely then we can fine-tune, train, retrain, do everything else. And I am sure that there is somebody in this audience who is very bright and very young, and we will have, right, into the future, an Indian model, right, as you very rightly said, which might be 10x of Llama. And that will happen from India, and I hope and pray that our young people will do that. But to start off with, open source is great.
That's right.
On top of that, right, all your tools. So the Foundry tools that we have, we are looking forward to a development center where we take core of your tools and train hundreds of thousands of developers in India to use all the enterprise tools, to use the Omniverse tools, so that we can really apply intelligence in a practical way. And to me, this is just the starting of this intelligence age. It's a multi-decadal journey.
Mukesh is talking like an engineer. You guys, listen to him go. He's starting to sound like a 28-year-old engineer. What do you guys think? I like it. I like it.
And that's why
that's awesome.
That's what we're going to do together.
That's true.
I can assure you
Thank
that
you.
like we did in data, in a few years from now, right, we will surprise the world with what India and Indians can achieve in the intelligence market.
Thank you. Mukesh, certainly we would agree that this is an extraordinary time for the world. And this is an extraordinary opportunity for India to have precisely the conditions to have such a large population and large industry of computer scientists at a time when this industry, the computing industry, is going to become the intelligence industry. Leveraging on everything that you have, leveraging on everything that you know, and your indigenous advantage, enormous amounts of data, a large population of consumers to drive that flywheel of intelligence to data, data to intelligence, intelligence to data, and have the national will to go do something about it. This is such an extraordinary time, and I am honored and privileged to be partnered with you to do this. And let's make it a promise today that we will work together so that India could take advantage of the intelligence revolution that's ahead of us. Okay, thank you very much.
Thank you. Thank you. Thank you. Thank you so very much. Thank you.
Ladies and gentlemen, Mukesh Ambani.
Thank you. Thank you. Thank you. And Jansen, my friend, right? You are here only a few days before Diwali. Diwali is our new year. It is where we worship the goddess of prosperity. So on behalf of all of us, we wish you a very, very prosperous new year, and to all of you, a happy Diwali and a happy
Happy Diwali, everyone.
Thank you. Thank you, my friend. That was good.